Hello everyone and welcome to today's SANS webcast, Analyzing Analytics, Turning Big Data into Security Intelligence, sponsored by Cisco. My name is Carol Auth of the SANS Institute and I will be moderating today's webcast. Today's featured speaker is TK Chianini, Principal Engineer at Cisco's Security Business Group. If during the webcast you have any questions for TK, please enter them into the questions window located on the GoToWebinar interface. We will be answering them during the Q&A session at the end of the presentation. And with that, I'd like to hand the webcast over to TK.
Thanks very much. Let's see, I should start with a bit of an introduction. My name is TK Chianini, and let's see, I began my career doing computer games for a company called Broderbund Software, and there I learned a lot about user interface and analytics from the point of gameplay. I quickly got into security. Was a CTO for Encircle for about 12 years that sold to Tripwire, and then recently I was the CTO for Landcope, which was recently acquired by Cisco in December. So that kind of gets you up to date as to where I'm coming from. The presentation today is around analytics. It's a term that I don't know about you, but I'm really burnt out on it. I mean, everybody's using it. You walk around the trade floor of any show, and everybody will tell you they do analytics. So what I wanted to do was put together a presentation that's very vendor neutral. It's just, it's basically a look at analytics in the broadest sense. And the outcome that I'm looking for is I'd like the sellers and the buyers in this ecosystem to basically have a more precise language around analytics. It's, at this point in time, it's like a musician coming up to you and saying they do music. It's not that helpful. So hopefully we'll have a more precise vocabulary and go from there. All right. So what does security analytics really mean? I think it's different for different personas. So the meaning of security analytics, I think we have to break down a little more and use what's called the knowledge pyramid. This is a structure by which I think there's a lot of abuse here. So people talk about information and they say data, or people talk about data and they say information. And these are really discrete categories, I think. And if we can clean this up, I think we'll do a lot better going forward. Definitely moving the market forward. So, at the data level, of course, you have things like syntax, and this is where machines do really well. Machines do data very well. Humans do not. And so recognition of that is, I think, paramount. And, also the thing about data is most of us have enough of it. We just haven't had the transformation to information. And that essentially is the byproduct of certain type of analytics. And then, on top of that, I put knowledge because, at the point that you're talking about knowledge, you're really talking about things that are more a part of human understanding. And again, I respect that a great deal. At the knowledge level, you have things like epistemologies, mental models. This is not an area where a machine can throw an error because it's really out of reach for machines. We're getting there, but a lot of the state-of-the-art reasoning engines that certain companies have right now are just at the edge. It's kind of maybe a toe into delivering some kind of human knowledge. And then, in the wise words of one of my prophets, at the point that you get to wisdom, which is sometimes how this pyramid is drawn, you're well beyond, you kind of get into the metaphysical, if you will. But again, we'll really be talking about data and information, and then maybe touching a little bit into knowledge. Excuse me. So when it comes to sort of data and information, there's certain qualities here that I think you as a consumer of this can demand more from your vendors, or maybe evaluate differently as you look at the marketplace. So, the thing about network data, I'm gonna kind of have a bias here. The thing about network data is no matter what the computing platform is, especially with even the explosion of different operating systems with IoT and everything else, everything is still talking TCP/IP, right? I mean, that is a common substrate, and because it's common across all data elements, it turns out to have a very unique property when used in the corpus of your analytics. So let's just take a quick look at this, because I think reviewing the stack is necessary here. So at layer 3 we have IP packets, of course. At layer 4 we have the transport layer and our friend ICMP. And then in TCP/IP you basically jump up to layer 7, which is where everything's just mashed in together, and it's everything at the application layer, and that pretty much sums it up. In that particular session there may be payloads, and of course that data is always interesting. Files, images, things of a certain length and size and encoded in a certain way. And that pretty much kind of summarizes most of what is data according to the network. There is, I made, concentrated in the last 4 years on NetFlow and IPFix, and for you folks not familiar with what it is, it's essentially the header side of everything that's happening on the network. And I always refer to it as the closest thing we'll ever get to a general ledger. This actually has the quality of being true for the bad guys and the good guys. If it's not in the clear here, it's not going to get routed, right? So it's a core part of internetworking. Then the other sort of interesting level of data is the session level, where you are getting application-specific type of metadata. So from HTTP you get URLs and things of that nature. From email, SMTP, there is basically RFC 822 headers, where you can have the to, the from. Even the error codes become interesting in analytics. And then of course, pick any session layer you want, FTP, NTP, Jabber. This again, all, if in the clear, is interesting to your analytics. And then of course you have document artifact, and this is specific to a particular application. So kind of looking at 3 qualities of this particular set of data. Flow data, of course, across the network can be incredibly complete, and that's sort of why I keep on referring to it as a general ledger to the analytics. And the rest of the stuff you really have to get down onto the hypervisor or onto a span port to actually get the raw capture. So again, you may get parts of the network, but actually having a visibility fabric across the entire network in some cases is not feasible. But flow data is, because again, the router switches, and also the firewalls at this point can exhibit these ledger entries, this flow data. So the other quality at the data level is availability. And again, by availability, I don't mean that you have taken delivery of the data. I mean that it's readable. Okay, so today, with all the encryption taking place, even if you're capturing everything that's going on in your business, if 80% of it is encrypted and you don't have the keys, I question whether it's even worthwhile keeping. If it's not readable, frankly, I would say toss it, because it's going to be the heat death of the universe before you brute force those keys. And then lastly, the scalability side, how does data scale? And while you can make the claim that everything fits in the cloud, if you're storing this stuff yourself, it gets there's a feasibility to this. And again, as you get closer up the stack to document artifacts and things of that nature, the volume of this data not only increases in a nonlinear way, but it also has a chance of not compressing very well. Whereas things sort of lower in the stack, these things compress like champions. So you have longer retention and things of that nature. Okay, so that's sort of network data, and while you can decorate it with all kinds of other things, I think because we are talking about the commonality of TCP/IP, I think it makes for an incredible candidate. Besides maybe time itself, it makes a good candidate to be a inverse functional property across a lot of what you're doing with analytics. Okay. Okay. So context and centricity. This is where we start to bring together different data sets and through analytics produce something informative, or to actually, this is the genesis of really where information sits. So I like to look at it always as a directed graph, and again, given a substrate of network transactional data and the completeness and the availability of it and all that we spoke of in the previous slide, I like to look at it this way, which is for a particular persona in your enterprise, whether it be security or IT ops, they have a different view of the world. And so, some of them are incredibly user-centric, and in fact, I think the popularity of user behavior analytics, which is a new category emerging, I think speaks to the fact that the shift from an IP-centric world to a user-centric world is useful, right? It has high utility. So a lot of people write algorithms that center on a user, but recognize that that's not the only way to do analytics. You can just as easily be application-centric, meaning where has this application connected to in the last 90 days? That's a very useful inquiry and a set of inquiries that you want to drive the analytical model to produce. Again, host-centric, even geolocation-centric, but you can just keep on going on and on. It could be IOC-centric, some kind of incident-centric type of analytics. You could have analytics that are focused on particular threat actors. Again, all of these being valid, all of these being sort of first class. File hashes, CVEs, I mean, you go on and on. My point here is that information, when it actually appears and is useful by the analytics, it has a certain centricity to it, a context. And I think as consumers of this, when we evaluate product, we have to ask ourselves, what is it satisfying? Because frankly, if something is just doing user behavior analytics and nothing else, is it still valuable? Or do I need an analytics platform that will help me render at inquiry time, at runtime, the type of centricity I need for this. So that's essentially what this slide's about: context and centricity, and hopefully we develop a more precise language here, so we can be better consumers and better producers of these properties. So the fundamentals of analysis, for me at least, go something like this, which is the only thing more important than the right answer is the right question. And again, in my years of working through these problems, it is in fact the case that a lot of facts in things kind of limit your investigation, particularly fighting what is called confirmational bias. You're just looking for data that sort of support your hypothesis instead of looking for other hypotheses. So questions, turns out, expand your human understanding of the investigation. And this is, again, something that's sort of on borderlines the information knowledge border. But I think we just need to respect this fact, because a lot of times we're looking for a dashboard to give us answers, where really we should be looking for interfaces that help us ask better questions. This is a really important thing, I think, in an analytical tool being useful. So in this section, I'm just going to kind of go through some vocabulary, because again, in my travels, a lot of this stuff gets abused. And I think until we have a more precise language here, vendors aren't going to be able to satisfy your needs, at least not precisely. So the one abuse I see most often is the term categorization versus classification. They are very different and non-trivial. So I think the poster child for the value of categorization is Netflix. In the case that the movies have certain characteristics, there may be a comedy, a drama, they get put into categories, and again, there are always those mashups of a romantic comedy, things of that nature. And all of this type of grouping is useful when you're looking for a particular movie. You may be the characteristic may be an actor or actress, director, but you can see that the data element itself, the movie, has many elements to it, and upon those elements you can actually categorize. As opposed to classification, which I think things like machine learning do really well, but this actually asserts a world that is inherently hierarchical. I don't know about you, but the IT world and the business world is a messy world to model. So it's oftentimes that for the highly technical or very domain-specific stuff, you may get away with actually a nice and pretty sort of classification scheme. But frankly, for everything else, it comes down to categorization, because the classification, at some point in time, things get messy. Like, I mean, even in Unix, the idea that we had to deal with symlinks, I mean, that's again, evidence of the fact that even in a pretty file system, the human is going to have to get something down in the hierarchy at some subclass and link it across the way. And at that point in time, classifications, in my opinion, really fall apart. But again, at the data level, I think classification has a chance, and that's again why I think a lot of people have really drawn themselves to what are called feature learning or machine learning. I have some links at the end of the talk for you can do further investigation there. But again, at the data level, I think there's enough domain specificity, and there's enough of a structure there to really get a lot of value out of machine learning, but as you get to the information and knowledge level, I think it really falls apart. Okay, so three terms that I think cut across all of analytics. I just want to call these out again because it is in my best interest that you become a smarter consumer of these services. The first is synthesis, okay, and the idea that it is an inductive process, meaning we're combining elements of sort of separate materials into something that is at a higher logical level a single entity, right? So, you know, the elements that are romantic comedies in Netflix, I think kind of fit this bill. I think, you know, here are examples of interfaces that bring us a synthetic process. So when I walk up to Bing and I say, you know, I need brown boots, it's going to synthesize a set of data that is the working set for me to then proceed along my analytical process. Google Maps, of course, you know, the interfaces here all have a way by which you are specifying some criteria to form a set. You know, think of set criteria. And that set is the working set. Not all data, not big data, just the most relevant data for the analytical process to take place. And so, again, based on user input, we render the most useful set. And I can't emphasize the importance of good user interface in all of this. Here we have analysis, and so, you know, the difference here is, as opposed to synthesis, this is a deductive process, meaning I'm actually now, with the working set, going to drill into the interface either to, again, ask better questions for, you know, more deductive reasoning, or I found my answer. So a method of studying the nature of something, right, and determining its essential features, I'm breaking it down. So, you know, an example is, you know, the grammatical analysis of a sentence, right? We're breaking it down. It's a deductive process. And again, you know, user interfaces that that go about this, you know, the idea of faceted browsing, I think, is a good example of this, because on, you know, always in the left pane, there's a way for you to see the groupings of criterias and make, again, more analytical deductions as the set becomes smaller and smaller, as, again, you are more insightful about refining what it is that you're going after. All right, and then the last thing I think everybody skips over, but is incredibly important, is the annotation function. And you know, I chose the most generic term here because it does take different forms. You know, when you look at the genius that was Flickr, and you know, you type in the word bear, okay. The problem is that in that 640 by 480, or in this case the 278 by 370 image, there is nothing in those pixels, in the syntax there, that would infer bear, okay? It's always through markup, and this is what I'm sort of lumping together as annotation. And this is incredibly important when it comes to data, because this is in fact the function that allows you to put your human understanding directly mapped to the data set. Okay, so the expert is now mapping their expertise language to the data, or the business owner is mapping their business language to the data. And this is actually when this happens, guess what, right? You can actually do synthesis and analysis on that terminology. And this is again where things become incredibly important to human understanding. We all know the hashtags that was brought to us by Twitter, but I'd like to call your attention to this, which is there is a gold figure on the table, and let's say there's 4 personas. In this case, it looks like a boy and a girl, a man and a woman. But for a second, imagine that these were roles within your enterprise. Let's say one is IT audit, one is investigation, and one is legal, one is, let's say, maybe even the CEO. It's actually within the tagging of this object that meaning is created. So the boy sees a dog at a bow, the girl here sees some kind of action, the woman sees antlers, and the man sees these other things. And it's actually through annotation that you're able to map these persona-specific vocabularies to the data set. Vendors that do this well treat this markup as first class. And what I mean by that is they are available to the analytical engine at the synthesis and analysis time. So that's really sort of what I call the knowledge process. Is it's a synthesis, analysis, and annotation, and round it goes. It's a real simple wheel, and I think if we think in these terms, we'll be able to develop and even talk about your needs as consumers in a better way. So, if big data is the book, then the analytics platform is the storyteller. This is sort of, you have to think of information and knowledge as stories, not necessarily data elements. And when you build a platform to do analytics, you're serving a particular persona. So, in this case, it may be an analyst or some other role in your enterprise that has a particular playbook or analytical needs, if you will. And the trick here is very simple. You want to render for Adam information, but not at the expense of Frank. Okay, and so what this tells us is, from a functional perspective, we need an incredibly late binding data structure. We need to have knowledge representation that isn't committed to Adam, because once we commit to Adam or Frank, we've really shortchanged the rest of the users of this analytical platform. And frankly, if that's your thing, that's fine. But what you're going to end up with is, if you have 12 personas to satisfy in your environment, you're going to have at least 12 different platforms. And we need another platform like we need another hole in our head. So again, we're trying to basically minimize complexity in your IT environment. So I'm going to actually go through this one section here that is a problem I ran into that might not be so evident to you. So if I can point out this pitfall early in your investigation, I may have saved you a few months or so. So the ability to compute membership to a set. And I ran into this problem because when I worked a lot in standards bodies, everybody was quick to sort of put a count on something. It's 3 of these, or it's 40 of these, or where is it from 1 to 100? But what they were ignoring was the fact that the thing being counted wasn't even semantically stable, meaning the thing being counted was being disputed by different people on the standards body. And I took a step back and I said, this is crazy, right? This is we can't even agree on what is being counted, yet we're quick to put mathematics to it. So it's a problem, and I hope I'll show you maybe a way around that. So numbers help us group things, right? In the credit world, to actually do the analysis to say whether you are credit worthy for a loan, there is a certain number set that you are basically put into, right? I don't know how easy it is to get a loan at 560. These, of course, aren't my credit scores. Only kidding. But again, it's everywhere. So, you have to be 21 to consume alcohol, or, you are considered a drunk driver if you have certain blood alcohol. So these groupings through numbers even go well into the legal system. We can make laws on them. So, we are all, categorized into weight classes, and this, may classify us as more risky or less risky to get life insurance or things of that nature. So these numbers are non-trivial. They really affect our lives. And they better be right, because frankly, if they're wrong, then, bad things happen, really. So again, we have economic classes, and then we even have age classes, right? So at some point in time, you get sent your AARP card or whatever it is. But in the end, all I'm saying is, in society, it's nothing new, right? Numbers help us group things. And so given a number within a social context, we can infer membership to a set, okay? So it's not the number that is the outcome that we're looking for. It's actually computing membership to a set, right? It's the criteria for us to be considered a senior, or whatever the class may be. All right, so this is sort of a real important point here: syntax versus semantics, and it's where at the data level we can be incredibly precise with syntax and completely fail semantics. And at the information level, frankly, we actually don't really have the utility of syntax. We only have semantics. So this is an important discussion here. So, when I look at this thing here, where I'm considering the nutritional facts of maybe a box of cereal or something, you and I know that this isn't everything in there. Like if I took a micron, a really good microscope and looked at these properties, there'd be a ton of other properties. But what's listed in this nutritional facts is only the elements that are relative to diet, right? So in most times you're just figuring out how much carbs, how much proteins, how much fats, or maybe you're just counting calories. That's sort of one thing of the observable domain. And so it actually, the point is, it helps us ignore everything else, because frankly we would get overwhelmed by data if I listed all the properties that exist within that cereal box. The problem here is that unlike the physical domain, before we can count things in the information domain, we actually all have to agree on what's being counted. This is where the problem of unstable semantics across different individuals in your enterprise may get in the way of actually you using numbers. So yeah, the challenge is that we all don't come from the same mental model, and in some cases you can kind of force that mental model, meaning like why I'm having this webinar and sharing with you the understanding of this domain, or why the industry requires you to go get a CISSP. It's mainly to stabilize the semantics of the domain. So number systems are dependent on social processes that institutionalize semantics. Okay, I think the poster child is the CISSP, right? Or basically any course whereby the institutional knowledge is stable enough for it to be put into some kind of institutionalization process, like the educational system, or even webinars. I mean, this is just how we go about doing things, and we've done this for years. The problem being is some of the domains we're modeling are changing faster then we can institutionalize this sort of semantic stabilization, and that's where we fall short. Okay, so one way of getting around that that I found, and it's an area of exploration that certain companies have taken, is not to think in the case of numbers, but to think in the case of sets. And so, you know, instead of seeing 3 blue triangles, we see the intersection of the set triangle blue and 3. And so it's a different way of going about the rigor that is formal logic, right? All right. So just before we break into questions, and I just want to give you a little bit of taste on this. Ontological reasoners, I'm not going to get too much into this, but let's just say that, you know, things that you use in your daily life, like Siri, Cortana, possibly Pandora, these are all things that behind it exists ontological reasoners that sort of escape this problem with numbers. And I'll give you a quick example of how they work. So I have a subject Jane, a predicate of has maiden name, and an object of Smith. And so in the semantic model, you know, domain and range can be used in models. So you can say that has maiden name has a domain and a range. The domain is female, and so by having that in the model, the reasoner actually can assert that basically Jane Smith is female, and because of our society and the stabilization of, you know, I guess culture and norms, has maiden name also can infer a domain of married. So Jane Smith gets computed as a member of married. This is also done without the use of numbers. Okay. So again, it, you know, has maiden name Smith, surname Smith, right? So I've just, you know, if this one piece of data element came into my reasoning engine, I've just inferred 3 other assertions from the semantic model. And so I put this together as a real simple example because you can understand how useful this would be in reasoning across the security domain. You know, the experts that SANS trains up on things like malware or incident response, these ontological reasoners could actually benefit us and also help us compute in a late binding way for the different personas. Incident response, I think, is the poster child to this because it involves legal, it involves PR, it involves IT ops, it involves all kinds of things. All of these personas trying to be satisfied by the analytics and yet sometimes greatly compromised by the tool. So, you know, it is, I'll tell you what the wrong answer is. The wrong answer is to go to PR and say they need to become security experts. That's the wrong answer. The tool should just facilitate facets of the data that are informative to their craft, their role. So closing remarks, real quick. We have to move just beyond syntax as an industry. Don't give me data. Basically, you know, respect each persona without compromise. I think we'll get there quickly. I think the user and entity behavior analytics market is going to be probably the hottest thing next year because it does satisfy at least one of these use cases. But the things for all those vendors to do is to look beyond just the user as a centricity. You know, today we have a lot of machine learning that we use because we are so data centric, and that's fine. Again, you know, statistical inferences are used a lot for behavior analytics. An entire category called feature learning is used. Again, these Wikipedia entries I think will give you a lot of homework if you're interested in it. If you're looking, beyond just where ML is today. I think a fertile area is an area called description logics. Again, there's a couple of things there that have come out. It's basically a first order logic type of rigor, but again, it does get around the number problem. Yeah, and continue to automate the experts and continue to augment the non-experts. That's sort of my my goal when I wake up every morning. So with that, I will take some questions. All right, let's see here. I'm going to start at the top, if you don't mind, chronologically. So the question here is, do you distinguish between analytics for operators' decision-making, tactical versus strategic? Good question. I think actually looking at that, I think the different personas in the organization have a different sort of daily life. They have questions they need answered on a daily basis. And for that, I think the analytical engine has to sort of earn its keep. You can take a longer view if what your task is planning, and there, again, that sort of daily report isn't going to really do you well. You want something on a quarterly basis or this and that. There should be no compromise to the analytical engine. Frankly, if there is, there's really something broken with that model. Another question is, do you really think we need different visualization platforms to support different roles? Or do we need to be able to specify transformation of the same data? Yeah, so interestingly enough, a lot of the UI UX, people have just chosen the lazy route. Again, my own personal opinion, it's whatever the open source software lets you do to visualization, and so innovation in that area, there's this basically 80% of the market, basically looks the same, and I think that all works out until it doesn't really, and so what really drives that for me is, in that one slide I had where I showed sort of a user-centric analysis engine, people who are thinking in terms of that mental model where everything to them is a user, the interface shouldn't be a bunch of lines and dots. I mean, it should look more like a user interface, more like LinkedIn or Facebook, right? So I do think the visualization has to really kind of match the centricity of the analytics. And if it's file-centric, then how do you visualize things that are file-centric? Certainly, maybe not, in a user way, right? More of a file way. So what is that? How does that visualize, and how do you make that more interactive so that these people can get to the answers, or again, better questions? All right. Let's see, TK, would you agree with hypothesis? And analytics are not one size fits all. Oh, hallelujah. It is absolutely not. That we know, right? That we know. There is no general case. And for anyone thinking that, you're going to be going down the wrong road, right? And so agreement and understanding the core decision and questions being asked. Yeah, so okay, so basically, what I take from that is it is the case that when you get closer, so at the data level, there may be some universal type of meaning, okay? But as you get to information and knowledge, it is incredibly personal. And why? Why is that? Well, because we are all different observers, right? It's closer to, again, I use the term epistemology, but it is closer to the epistemology of human knowing than it is the data that a machine can process. So I think that's why that specificity is so important. Okay, so how do we govern the data and how to allow for most of the Franks and Adams? You know, so here's another term to look up on Wikipedia. It's called knowledge representation. Okay, and it's a general term used in AI because a lot of people think, oh, you know, let's just put the data in this repository without, you know, a whole lot of thought given to what type of knowledge representation they're putting together. And that actually sets up some incredible constraints to what type of analytics can be run. So my statement there is that the knowledge representation creates either affordances or constraints on the type of analytics that can be performed. So what a lot of architectures do is they pick the most sort of generic horizontally scaling repository, right? So something just, you know, key value pair or even an RDF store or whatever, but it's very, very simple. And then they use a polyglot type of architecture. So, you know, I pull from that into a relational database or even a column store for certain types of analytics. And I pull from that into a graph store for different other types of analytics. But you can see that instead of having a commitment to column, relational, graph, or anything else, I'm actually using a generic horizontal store that has very little form. And I'm actually positioning the form of the data or the knowledge representation closer to the user to facilitate the types of analytics they need. And that is really a late binding architecture there. All right. Like the recommendation for semantic models, but have you successfully worked within semantic? So, you know, scale's always an issue. So, I mean, basically, you know, you're asking, do semantic modeling scale or not? I think, you know, testament to it actually working incredibly well is, you know, Microsoft buying PowerSet and coming up with Bing. All of that backend is based on ontological reasoners. Siri, before Apple bought them, you know, Gruber he's actually quoted everywhere as defining what ontological reasoning is about. So Siri, which I would argue scales quite well, is based on ontological reasoners. There are some open source stuff out there. You know, can we improve on the scaling? I think always. You know, a lot of other people, there's another camp using sort of Titan graphs and just straight up graph theory. While faster, maybe, it is very application programmer specific, which is kind of why the developers like it so much. I'm less attracted to it because I'd actually like to put the modeling not in the hands of the developer, but in the hands of the consumer. I want every consumer to be able to model their environment, which is, you know, why I use that term annotation very strongly about a feature set. So yeah, I do think all systems have scale issues, but I definitely wouldn't just blanket statement say, you know, semantic modeling doesn't work because it doesn't scale. That I would probably not say that. All right, I think we may be through all the questions. I really appreciate you folks listening. As you can tell, I'm very passionate about the subject, and I look forward to, you know, learning on a daily basis on how to do this better. So thank you again for joining the webinar.
All right, thank you so much, TK, for your great presentation, and to Cisco for sponsoring this webcast, which helps brings this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, you can visit sans.org/webcasts. www.cisco.com/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.